Starting back up with test 3 from the 6 paper tests on College Board. This is going to be module 1 of math continued. This is going to be part 2. So jumping into number 9 here, it looks like we got some sort of graph. I'm going to scroll down a little bit. And not many labels, nothing for the axes here. We do have a line with a slope. It looks like we also have some sort of y-intercept here, right? Let me make that a little bit bigger. And yeah, some sort of slope here, some sort of positive slope, right? So the graph represents the total charge in dollars by an electrician for X hours of work. So the whole point of practice isn't just to get the right answer for these specific problems, but to kind of maximize our understanding of these types of problems so we can always get them right. Because remember that the questions you see on your actual test aren't going to be this, they're going to be changed. Different graphs, different numbers, different context. So as soon as I see this electrician is working X amount of hours, I want to try to form my y equals mx plus b equation, right? So if I kind of write that up above here, if I say, okay, y equals mx plus b, try to help me with maybe some of my labels here, right? So my X hours of work, okay, so maybe like 1, 2, 3, 4, 5. So as, you know, the longer this person works, the more money they make, right? Because at 1 hour, I make this much, at 2 hours, at 3, at 4, and at 5. And right there, we should be comfortable with also our y-axis. Our y-axis, always try to think of it as some sort of total, right? Because our equations are always y equals, think of this as maybe like a total cost, right? The amount this person would be charging for this amount of hours worked, right? But there's also one more thing to notice here, maybe two more kind of to notice. So there's two things this person is charging for. There is our slope, right? This is like maybe for 1 hour of work, we charge, I don't know, $50. But there's also this right here. At time 0, we're not starting at total cost of 0. We're starting at maybe, let's call that like $30, right? So that's going to be this initial cost, maybe like a down payment to have the electrician come to your house, because maybe it's only going to take them 30 minutes to fix this problem. So they need some sort of incentive, right? So we always want to think of our y-intercept as this, as our b. And then in this specific problem, we kind of made up our rate, and we're going to call this 50. So our equation that we kind of made up for this problem would be y equals $50 per hour. X would be our hours, plus $30 as like this initial payment. So let's finish reading the problem. They charge and we already anticipated this, they charge a one-time fee, we called that 30, plus an hourly rate, we called that 50. What is the best interpretation of the slope? Again, that's why we flesh these problems out. We know that the slope of the graph is our m, is our 50, that is our hourly rate, or A for number 9. So again, these practice videos aren't going to just be, you know, in 30 seconds how to get the answer. You'll be able to do that on your own. I want to show how we can master these questions, so when you see a problem like number 9 for the 3rd, 4th, 5th time, you can solve it in 30 seconds because you know every way around the problem. So jumping down to number 9 here, or number 10 here, let's see what we got. Square X has side length of 12, pause, right? We want to develop the toll set for when to approach a problem in a segmented way and a non-segmented way. Like some problems, you're going to want to finish it because there might be a shortcut. With this one, if I'm drawing a square and it has sides, I'm going to draw it right off the bat. So we have X, and it has a side length of 12. So I'll just label all sides just in case, you know, I need that little reminder. Maybe they want area, maybe they want perimeter, and they tell us something else it looks like here. The perimeter of square Y. Okay, so square Y is 2 times the perimeter of X. So we do want perimeter. So perimeter is just going to add up our sides. So 12 plus 12 plus 12 plus 12. It looks like perimeter for this one is going to be 48. And they say Y is 2 times. So let's get a different color here. Perimeter for this one over here is going to be, you could throw it in your calculator if you want. It looks like it's going to be 96 if I multiply this by 2. So all we would really have to do if you wanted to throw it in your calculator, remember it's 4 sides, 96 divided by 4, or it's just going to be 2 times this, right? If I did 96 divided by 4, I'd get 24 for each side. or I can just recognize that doubling each side is going to also double my perimeter, right? So they want to know what is the length of one side of square y, and it's just going to be 24 here. So this one, no other really rules to go over, not too bad. Yeah, we'd be glad if they include these tests or these problems on our tests. And jumping all the way up to number 11 here, let's move this over and let's get rid of a little bit of this writing here. Okay, so this one is, I see an equation. What is the equation of a line that passes through the point? So we have a point and is parallel to this. Let me erase that. Let's make it a little bit nicer. Okay, so this is going to be good for the SAT and maybe your math class too. There's going to be all sorts of combinations of this: 2 points, a point and a line, comparing slopes, etc. Right? You could use Desmos for some of these. Anytime it's 2 points. So anytime it's 2 points, it's really easy to use Desmos. So I'll kind of just show that, right? So if I pull up Desmos here, and let's make it a little bit more of the screen. So if I had 2 points, let's say, well, let's show first how I would do it. So you go to this little plus sign here and you make it a table and you just plug in your 2 points like this. So say my point is 1 for my X and 5 for my Y, and then 6 for my X and 11 for my Y. And then I just hit this little 4 dots in a line over here and it gives me my equation of my line. So that's really nice. That's for if you have 2 points, and that's just so you don't have to solve for it. For this one, we get 1 point, and then they talk about our slope. So let's just try it, right? You want to be able to solve this by hand because in your math classes, you'd have to know this anyway. And when we do see an example with 2 points, we'll do that too. So when we have, I feel like we'd have to know what this is, right? When our lines are parallel, they're going to have equal slopes, right? So when my lines are parallel, their slopes are going to be equal to each other. So what I would do is I would start with maybe my y equals mx plus b, always start with this, and then start to fill in units as you get them. So they tell us that it's parallel to this, so that I know my slope is going to be the same. So y is equal to 7x plus b. And to get the full equation of a line, we only need our we only need our m and our b. We have m. But to get b here, think about it. If we want to be able to solve for b, I need an x and I need a y and I need an x. Did they give us at some point an x and a y? And the answer is yeah, right here. They gave us this point, which is an x and a y. So to get our b, you're always going to have to plug in a point. So I plug in 0 for my x, I plug in 5 for my y, and I get 5 is equal to b. Not so bad. So then my final equation should be off to the left here. Y is equal to 7x plus b, or plus 5. And I think I see that in letter choice B. Let's make sure. Yeah. So 11 is going to be B here. This is great practice solving by hand. Desmos can help with questions like this, but knowing how to solve them by hand is probably going to be really important for your math classes anyway. And you can still solve them by hand fast enough for the time requirement for the SAT. So great problem. Let's go ahead and try number 12 as well here. So number 12, let's change colors. Oh, another linear function, h. So this is our line. H of 0 is equal to 41. So right there, remember that you're probably used to seeing either h of x or probably usually f of x. So remember when they plug a number in here, you're replacing your x. Just try to think as logically as possible. If I'm replacing my x in parentheses with a number, then I probably replaced my x in the function with a number. I glance up above though, and there is no function. So remember that for next time at least. This one's a little bit odd. They say when my x is 0, let's try a different approach. When my x is 0, right here, my y is going to be 41. Okay. And what's the second thing they tell us? When my x is 1, my y is 40. So there's a lot of ways you could go about this. There's the systematic way, which we could just use Desmos. But what if we tried a logical approach first and then checked with Desmos, right? So when my x is 0, my y is 41. So it's almost like y is equal to x plus 41 because my y-intercept is 41. And then when my x is 0, I get 41. But then when my x increases by 1, it goes down 1. So I'm thinking maybe there's a negative in front of my x, because -1 plus 41. I see that nay, and yeah, I think that is going to be our answer. But I wonder if there would have been a systematic approach to try this, right? These are 2 points, aren't they? They are. What if I threw these 2 points in Desmos just to make sure? So 041, 140. Let's pull Desmos back up here and make a new table. So I think it was 041 and then 140. Let's make a line, and there it is. So this is going to be the systematic approach to how to do it. There's the logical approach. There's the, we could do, oh yeah, let's practice also doing by hand, right? So this was kind of just like a rational approach, but let's try the actual like algebraic approach, right? So let's erase this. I'm going to try to make some space up above here. So another way to do it is to do, and again, you've probably heard this in your math class, your change in y over your change in x. So what this is going to help us get is our slope of our line. So off to the left here, I got some space. I'll make our line. Y equals mx plus b. So remember that the only things we're ever solving for in these are our m and our b. This is going to be our slope, and this is going to be our y-intercept, right? So to solve for our slope, we do our change in y over change in x. You've probably heard it as y2 minus y1, x2 minus x1. However you want to think about it, as long as you go in the same direction. So like I probably want to do this way, so then I'll have to do this way. So change in y, 41, or how much am I changing from 41 to 40? It's going to be positive 1. And then how much am I changing from 0 to 1? I'm losing 1, negative 1. So then my new equation would be y equals negative x plus b, because I'm just throwing a negative in for my m, or a negative 1. I can throw a negative 1 in there. Let's change the color. And then to solve for b, you just have to plug in one of your points, right? I'll choose this one. So I plug that point in, and this is my x, this is my y. So 41 is equal to negative 0 for my x plus b. And it looks like 41 is just going to be equal to b. So same thing, we get 41 for our y-intercept, we get -1 for our slope. So a lot of different ways to solve for a here. Excellent problem, not too bad. But yeah, so this will be the page for today. I uploaded a bunch of other shorts too if you want to go through those individual problems. And yeah, we'll be jumping back with part 3 tomorrow.